All right, so let's look at the critical value. First off, you should notice I can see that I don't really, actually I'll do it real quick. When I click over here, you put in negative 1.28 and 1.28. That's not correct because uh, you have a right tail test, as you can see. As you, I mean, you got your null and alternative hypothesis correct. So that means that there's only going to be one tail, so you should only have one critical value. You have two critical values when you have a two-tail test. So when your alternative hypothesis is not equal. Okay, so let's look at this. Um, let's see how we get 2.33. So since we're dealing with a normal distribution, we want to use the normal calculator, and the critical value is based off of alpha. The area, the alpha is the area on the tail. So you may not be familiar with using StatCrunch for this, but StatCrunch is just really easy to use once you know how to use it. And there's tutorials on how to use it in the classroom, but maybe you didn't take a look. I'm not sure if this is the way you're doing it, but this is the way that it's suggested using StatCrunch in the course. And once you start using it, it's just everything's really quick. So first off, it's a right tail test. We can see it's a right tail test. So we want greater than, we want the right tail. And we want the right tail to be equal to alpha. So that's 0.01. And so there we go. The right tail is 0.01, and there's our critical value. Remember, the critical value is where the area to the right of the critical value is alpha. So, and since we're dealing with normal distribution, this is how you do it. And I mean, that's all you do. And if you're doing a two-tail test, you just want to do between and base it off that. Having the area of the two tails add up to whatever alpha is. So you have to split alpha into two and go from there. So anyways, okay, so that's how you get the critical value. Now the standardized test statistic. To find that, you want to use, you want to think about the test we're doing. So we want to go into stat, and we're dealing with proportions here. As you can see, we're dealing with proportions. And so we're doing a proportion stat to sample. And notice that we don't have raw data, we have the summary. So with summary. So now we want the successes and observations. Let's see here. Assume that the survey included, assume, okay, actually, I'm not even sure what this question's talking about. Let me see here. Okay, referred, blah, blah, blah. You can support the claims that the proportion of women aged 18 to 24 living in parents' home was greater in 19 than 2006. Okay, yeah. So we have, I'm gonna have to add this up, but the total number of so successes. So we're talking about women, percentage of women. Um, Successes represents women because that's what we're interested in. It's the claim the proportion of women aged 18 to 24 living with their parents. So we want percentage, the successes of women. So notice that there's 13,000. Okay, so 1999 represents sample one. Okay, so assume that in 1999 men and women. Okay, so here's our numbers right here. So we want successes to be represent women, so that's 13,000, and the observations, it's total amount, so that's 12,900 plus 13,000, that's 25,900. Just add those two up, the men and women. So there's 25,900. And and there's 13 men and women, the observation in 1999, and then here's the amount that are women, And then looking at 2006, we have 14,600 women. And 14.3 plus 14.6 is 28.9. Okay, and okay, so P1 minus P2. So we want we want greater than. And to think about this, we can subtract P2 onto the left side, and we would end up getting this for the alternative hypothesis. And you almost always have 0 here. Don't worry about that. You would in this case. And then we're ready to compute. So hopefully you see what I did here. At first, you need to figure out which test are we doing. We're dealing with two-sample proportion, and we have summary since we have the numbers here. Data would be just raw data, like 25,900, either men, women, and just individually you'll have all men, all women. This is just a summary of the counts of each. So get the summary. And that's how I ended up finding all the information. Then you compute, and there we go. Here's the z-stat, here's the p-value. So the standardized test statistic z is right here, z-stat. That's how you go about doing this. Let me know if you have any other concerns. This one can be a little bit challenging because you have to kind of interpret what they're looking at, proportion of women. You're looking at proportion of women here. So we want, so successes is women, and the total amount is men plus women. So you have to know to do that to find the values that go into this data sheet. So let me know if you have any other concerns. I'll be more than happy to help.